Okay, now we move to section 1.8, which is talking about quadratic equations. Again, quadratic equations are polynomial expressions set equal to 0, which has as the highest degree is 2. So a polynomial of the second degree is called a quadratic expression. One way to solve these quadratic expressions is using factoring. Another way is to use the quadratic formula, and we're gonna look at both of them, do some exercise. I think we're gonna have 4 of them, 4 exercises in this section, which would use both. Let's look on section 1.8, number 16 first. It says solve the equation by factoring. So number 16, you have 13m equal minus 5 minus 6m squared. Again, you set this, we know this is a quadratic because the highest power for the variable m is 2. So we move everything to one side and set it equal to 0. You would have 6m squared plus 13m plus 5 equal to 0. Now to factor this, again, we put 2 parentheses equal to 0. We'll look at the first term and say, what can give me 6m squared? Again, there are different combinations. You can have 1m times 6m, you get 6m squared. You can have 2m times 3m. That also give you 6m squared. Let's try 2m and 3m. And if this doesn't work, we would change it to 6m and 1m. If we have 2m and 3m, then you would look at the constant, which is 5. The multiplication of 2 numbers should give you 5. Well, basically is 1 times 5. Now, would the sign be both positive or both negative? Because either one of them would give you a plus 5. Well, my answer would be it has to be both of them positive, because this here is a plus 13m. Now, where would 5 go and where would 1 go? One way, of course, let's say here you have a plus 5, here you have a plus 1. Let's see what happened when you factor them this way. We multiply the terms. 2m times 3m is 6m squared. We are fine. 2m times 1 is plus 2m. 5 times 3m is plus 15m. And 5 times 1 is plus 5. When you simplify this, would be 6m squared plus 17m plus 5. Well, here it gives you 17m, but you had to come up with 13m. So this position of 5 and 1 this way is not correct. So let's switch it and put it 2m. Instead of plus 5, you put plus 1 times 3m plus 5 equal to 0. Now, if you multiply these 2 parentheses together, you do get the original equation. I'm not going to do that now. Now, you have the multiplication of 2 terms equal to 0. So that means 2m plus 1 equal to 0, or 3m plus 5 is equal to 0. If 2m plus 1 is equal to 0, that means 2m is equal to minus 1. Therefore, m is equal to minus 1/2. And here, 3m equal minus 5. M is equal to minus 5/3. These are the two answers to the equation. Again, you can look at the examples and self-check exercises in addition to the problems we do here to help you understand the material. Let's go to another problem, problem number 26. Number 26, it says solve the equation by completing the square. You have 7p squared minus 20 equal to 0. One way to solve this, since we don't have basically any middle term, we can solve this as 7p squared equal to, take 20 to this side, to the other side, it would be a plus 20. And therefore, p squared would be equal to 20 divided by 7. Take the square root from both sides. That means p would be equal to plus or minus square root of 20 divided by 7. Whatever that number is, I'm not interested in. So we would have two answers, plus or minus 20 divided by 7. Let's look at another example. Let's do number 44. Problem number 44 is a little bit different, and it already gives you a hint. So there is a sort of creative way you have to solve this problem. You have t divided by t minus 1 squared minus 2t divided by t minus 1 minus 3 equal to 0. It gives you a hint. It says let x be equal to t divided by t minus 1. Well, this is a very important hint. And that, by the way, is this or this. So in other words, this can be written as x squared minus 2x minus 3 equal to 0. Now you can solve for x by factoring x here, minus 3 plus 1. If you multiply these together, you will come up with the quadratic equation you have on top. Again, x plus 1 times x minus 3 is equal to 0. So that means x plus 1 is equal to 0, or x minus 3 is equal to 0. X plus 1 equals 0. That means x is equal to 1. X minus 3 equals 0. That means x is equal to 3. Now, you recall that x was t right here. X was t divided by t minus 1. So that would mean t divided by t minus 1 equal to 1, or t divided by t minus 1 equal to 3. Now we solve each one of these. So here you would have, you can give a denominator of 1, do a cross multiplication. So that means t is equal to, that is 1 times t, and then that multiplied by that. So t equal to t minus 1. So here, well, actually this t and this t would cancel, so you have 0 equal minus 1. So there is no answer you can get out of here. But here, you do again cross multiplication. It would be t equal to 3t minus 3. So when you move the t to one side, you get 2t equal to 3. T would be equal to 3 half. That is the answer to this problem number . Well, I'm going to take this back and tell you that I made a mistake. Some of you probably already caught it, but that's okay. Right here, when we solve this, x plus 1 equal to 0, that means x would be equal to minus 1. So the calculation I did here is not correct. Even though I can start taping differently, but let you understand that mistake can happen. So this is t divided by t minus 1 equal to minus 1. So you give a denominator of 1, that would be t equal to minus t plus 1. Therefore, 2t equal to 1. Therefore, t is equal to 1 half. Now this is correct. Two answers, t equal 1 half and t equal 3 half. These are the two answers. Let's see, I think we said we're going to do one more problem from this section. Let's see, we got problem number 74. It is an application problem. The golden ratio. It says consider a rectangle of width x and height of y. See the accompanying figure. The ratio r equal x divided by y, satisfying the equation x divided by y equal to x plus y divided by x, is called the golden ratio. Show that r is equal to 1 half times 1 plus square root of 5, which is approximately 1.6. And it gives you a note after this problem. It says a structure or a picture with the ratio of width to height equal to the golden ratio is especially pleasing to the eye. In fact, this golden ratio was used by ancient Greeks in designing their beautiful temples and public buildings. Right? You have a nice picture down there. Right? So if you become a builder, you know to keep this ratio. So let's see what we have to start with. Again, this is problem number 74, talking about golden ratio. X divided by y equal to x plus y divided by x. And then, as you can see, they solved for r. Let's assume x divided by y is equal to that ratio we are talking about, is equal to r. So what I'm going to do up here on this side, I say this can be x divided by x plus y divided by x. And of course, x divided by x here would be 1. So that's 1 plus y over x. Therefore, what I have here, x divided by y, which I'll call it r, is equal to 1 plus 1 over r. this is an equation, and I want to solve for r. To do that, let's multiply everything by an r, both sides of the equation. I can do that. That does not change the value of the equation. So what I would get is r times r would be r squared equal to r times 1 is equal to r, and r times 1 over r is equal to what? 1. Therefore, I have r squared minus r minus 1 equal to 0. To solve this quadratic equation for r, I'm going to use a quadratic formula, which basically tells me r is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Again, a, b, and c are referring to coefficient of r squared, coefficient of r, and the constant, respectively. So here, r would be equal to minus b is the coefficient of r, which is minus 1. So minus b would be a plus 1. So 1 plus or minus square root of b squared is minus 1 squared, which is 1, minus 4 times a is the coefficient of r squared, which is 1, times c is minus 1, divided by 2a, which is 2 times 1. Therefore, r is equal to 1 plus or minus square root of 1. You have minus 4 times 1 is minus 4 times minus 1 is plus 4. Let me get rid of some of these extra spaces. Divided by denominator, which is 2. Therefore, it is equal to 1 plus or minus square root of 5 divided by 2, which is, as it says, the golden ratio. This is similar to r equal to 1/2 of 1 plus square root of 5. You are disregarding the negative here because you cannot have a negative ratio. Either the width or the length can never be negative. That's why we are disregarding the negative answer. Only look at the positive, as you can see here. Only look at the positive.